Evening, everyone. Thanks very much for coming along to my talk. So I'm going to talk tonight about how to treat your shiny data platform as production infrastructure. So first off, boring introduction. Been at this for 25 years, doing that mostly as an automation engineer of some sort. Some points it's been called Perl, at some points it's been called Puppet. These days it's called AI, but it's all about automation. In the last 5 years, I've been working in aviation, helping airlines get to the clouds. And if you think that's the last aviation pun you're getting this evening, you're much mistaken. So this is a technical talk. Most times when I get up on stage and talk to people, it's about abstract concepts, about how to avoid failure by failing early, or how to do DevOps-Exchange by getting people together. So if you're not happy with the technical talk, the exits are here, here, and here. So, ClickOps is not okay. If you walk away from this evening with one thing from me, it's this. That's why I'm here to speak to you this evening. ClickOps is not okay, right? So, we're really good in DevOps at dealing with cool platforms like AWS and handling those with infrastructure as code. But what I keep seeing in organizations I'm working with is they've got infrastructure as code for AWS, but then they'll bring in PagerDuty or OpsGenie or GitHub, or in the case of what I'm going to talk tonight about, Databricks. And then they'll start ClickOpsing in UIs and doing whatever they want to it. It's just complete and utter arrogance from people like me. And I'll be clear, I'm guilty of this. I've done this, right? People like me should not have the power to change how an enterprise works by sitting at their computer and clicking in a web UI. It's not okay. So ClickOps is not okay. But why? Why is it not okay? Well, the answer's in the question, right? It's why. So if you think about clicking around in these UIs, so say GitHub as an example, there's an audit log. People can see what I've done, but they've no idea why I've done it, right? That's why we do infrastructure as code in the first place. AWS has a great UI, a fantastic web console, a CLI, and I can see everything you do as an admin, right? I've got the ability through the various audit mechanisms to know what you did, but I have no idea why. And I can't see at 2 in the morning why you decide to delete the production S3 bucket. Hopefully, if you do that through infrastructure as code, you're gonna comment in your Git commit to say, well, I had too many beers tonight and this seemed like a good idea, right? So why is the reason, right? So that's why we do infrastructure as code, and it's why ClickOps isn't okay. And it doesn't matter whether it's AWS, of course we're hosted here, so I'm going to keep saying AWS, other cloud platforms may be available, or it's Databricks, or it's GitHub, or it's any of these other platforms. So what I wanted to do is take what I've done the last 5 years and show everyone. But it turned out the airline wasn't really cool with me publishing all their code. I don't know why. It's actually pretty good, but they're not. So all I can do then is I thought, well, how can I publish the patterns that I've worked on? And it turns out my own cloud usage is rather vast and expansive. It covers AWS, Azure, Google, Databricks, OpsGenie, GitHub, and so on. So I decided that I would cover all of my own cloud usage with the same patterns that I've deployed in various other companies. And so there's this repo in GitHub that you can look at after a talk under my username, and I'll publish the links, called GitOps environments, as an example of how to do GitOps at scale with multiple clouds all at once. Now, the advantage of this, the reason I set things up this way now, whenever I'm going into a new organization, is this is one repo that controls every cloud within the organization. So actually, I had a new person today in one of the companies ask me, because I'm leaving there soon, hey, can I get a brain dump from you? Can I get lots of documentation? And I gave him the worst answer possible. I said, well, I could write some documentation, but actually it's all in the code. And it's a really terrible answer, but it's also true. The entirety of that organization I'm about to leave, everything they do in every cloud platform, whether it be GitHub, Lacework, AWS, Azure, Databricks, is all in one repo, in one place. You can see every environment, you can see every deployment, you can see every configuration. In terms of discoverability, it makes things very easy. So the structure of this public repo very closely mirrors what's been done in private. And there's two important parts to the structure. One's the directories. So at top level, you've got clouds. Then underneath that, you've got the accounts within those clouds. Now, I got to be clear, this is a suggested structure. It's not going to fit for all organizations. There's one other organization I'm working with. They've got 1,299 AWS accounts. I'm not sure I put those all in one directory, right? So maybe if you are going to copy this template, maybe fit it to your organizational needs. But as a suggested structure, it works pretty well at most scales. Underneath there, you've got environments, modules, which are then deployments. Now, if any of you have not used TerraGrunt before, I highly recommend it as a wrapper for Terraform or OpenTofu. That then lets you deploy a Terraform module, this TerraGrunt.html, and I'm going to cover that in a minute. The other reason I'm a big fan of this structure and of TerraGrunt itself is that underneath that structure it allows you to have inheritance of your environment variables, of your inputs to your Terraform modules. And so in this repo you see is a global.yaml, right? And that global.yaml can be things that are particular to the entire organization. And in all of our organizations where we work, we've all got these things, be it the name of the organization, be it certain prefixes we might use within that organization. Please don't let it be default passwords. Please, please, please. Right? But we've all got things in there that are particular to the organization. A level underneath that then, the clouds directory, you get auto-included the cloud.yaml. That then gives you defaults for your cloud provider. Maybe you like to deploy in the Irish region for AWS. Maybe with your GitHub repos, they all want to be private because you don't like to share your code. But it can be whatever's default to that cloud provider. But as I said, this is technical talk, so I'm not going to bore you with code on slides, the worst thing to do with slides. So at the cloud level, and I'm going to use Databricks as the example here because it's one of the things that people wouldn't typically control with Terraform and that I'm trying to encourage that you please do after this talk. So at the cloud level for Databricks, what you've got here, in TerraGrunt, you define your remote state bucket. It goes and creates this and manages it for you. So that whole bootstrapping thing of, well, how do I start using Terraform, it solves for you. So you just tell it the bucket name you want to have, and then you tell it that for everything it's going to deploy, use the path you've got in your repo to store the state file. So you've got a separate state file for our deployment. And then the second set of lines here, the inputs, that's where you get this auto-inclusive inputs to your module. So that's where it pulls in the global.yaml. It's where it pulls in the cloud.yaml for that particular cloud. So then underneath that, thinking about actual deployments, so I've got an example there of using Databricks. And what this gives you here is the first 3 lines there. That's the Terraform module or OpenTofu module you're going to pull in. Below that, the next lines in there, they do the include. So that's what pulls in the previous file you've seen, the cloud level terragrunt.html. Below that, you get to override files within the module you're using. So I'm just using this to say, actually, your backend's in S3. And then the last section here is the inputs for a module. So in this case, for the Databricks workspace, what we've got is the AWS region. We've got the workspace name, which I'm hard coding. We've got the VPC CIDR, my account ID for Databricks, and then some tags. Now, the tags and various other pieces like this, I probably do that through inheritance usually. So I'll probably pull in my account ID through the cloud.yaml. I probably pull in the environment through an environment.yaml that I put in the environment directory, but that's more slides and more code. So I just put them all in here in the TerraGrunt.html for you to see. Right. But this pulls in a module for creating a workspace in Databricks. And so part of what I want to cover tonight as well is to encourage more of this deployment of infrastructure as code, control of AI tools like Databricks, the same way you would control, I should say, your AWS AI tools in Terraform today, because of course that's what you're all doing. If you are using Databricks, I've now put up this public module collection. So the first one, which I'm about to demonstrate, it creates your AWS workspace for Databricks. There's one for S3 storage credentials, and storage catalogs about to come. And I'm working with a team which is starting the Databricks usage within an organization. So as they start using more features of Databricks, we'll produce more modules and publish them out. So here's a very boring video that hopefully should just work. There we go. So if you've ever used Terraform before, it should be pretty familiar to you. You run tergrunt apply. It's the same as running Terraform apply or tofu apply. It gives you this output. I typed in yes straight away because it's dev, of course, and then I realized, oh, I should probably look at the output and all these lines and pretend like I'm reading them and I'm actually understanding all these various changes it's going to make to my cloud. Well, it's opening up all these firewalls and, oh, wow, there's so many lines, I'm already bored. Yeah, it's going to give all these EC2 permissions. That must be good, right? Let's keep going. Okay, wait a second. What? It's going to sleep? So the sad thing about this module is it does use a sleep provider in Terraform. I found a bug where when creating a AWS IAM role, if you then go to use that AWS IAM role, even if you depend it in Terraform, for those of you familiar with Terraform, you can depend one deployment on another. AWS in the back end isn't catching up fast enough. It's returning your API saying the IAM role is created, but it takes a couple of seconds before it is. So in Databricks, I can't call that AWS IAM role without putting in its wait. It's a bit boring. But what it's doing here is it's creating all the AWS side of the infrastructure that Databricks needs to be able to create the virtual machines for the clusters that Databricks is going to use to run all your cool data queries and all the data you're going to throw at it. And then it does the clever part at the end once it gets through all this and creates the Databricks workspace as well. So you get management of both of the cloud platforms in one module, easily deployable, easily versionable, and you can see what someone's done. I think this is particularly important with tools like Databricks, where you're bringing all of the data for your entire organization into one tool. You know, the potential exposure, the potential problems with a tool like Databricks are pretty serious. One of the things I like about this video, and wow, does it feel like it's going on a lot longer than it did when I ran it, is that I've noticed in the last 5 years that the AWS APIs have actually got a lot faster. So it's taken a little bit of time here creating the endpoints. But in fairness to AWS, 5 years ago, these were timing out in Terraform. So they have got a lot faster. AWS have done a decent job of improving these. Of course, I have to say that because we're sitting in AWS, right? But there we get to the end, almost exactly on time. And you can see here it's creating the Databricks workspaces with Terraform as well. And what it's going to output at the end is the name of the workspace. Now, this is one of the other reasons I like the structure that I've put up with Tergrunt, because you can, across clouds, take the outputs of one Terraform module and feed them into another. So you'll see it's outputted the Databricks host. Well, the cool thing about that is I can then pull that into the modules for deploying the S3 buckets or anything else, because that's the host of the workspace I want to create those in. And I can use that anywhere else in AWS or any other tool I need to, or any other cloud I need to. And so just to prove that I'm not lying, I then went into the Databricks console. This is my account. Checked the workspaces. That's my brand new workspace that was created. I'm sure you're all paying deep attention to that URL from the last video. So you can see the URL is the same here. I can see that Databricks is wonderfully secure, so it doesn't even give my user permissions. So I've got to go and add that manually. That's something to be added to the module. And of course, when I'm searching my name and adding my permissions, well, you know, I'm a massive cowboy, and so I give myself admin permission so I can go and click ops around that workspace that I've just created with code, right? But the important part here is you can see that the workspace was created with the code. I mean, log into the workspace. There's the URL again. And boom, boom, boom. Cycle, cycle, cycle. And workspace is there. And so I'm going to save you the boring trip tonight of seeing a Terraform destroy run. But I did that in the background with this as well. And there, workspace magically gone as well. I've saved all that money. Again, just to demonstrate the infrastructure of code all does what it says it does on the tin, and you can go and use this module reasonably safely when you go home, which I'm sure you're all going to do tonight. So what's next? Well, first off, it's more modules into a Databricks collection. So because I'm seeing more and more use of Databricks, I'm going to publish more of these modules to make sure you can control all of Databricks with Terraform modules. This is all being done in the style of the Terraform AWS modules collection. And if you've not seen that and you do use AWS with Terraform or OpenTofu, I highly recommend you go have a look. I instruct everyone I work with to try and not write any Terraform code, to use modules when they're dealing with AWS from two specific collections. The first being the Terraform AWS modules collection, the second being from a consultancy called Cloud Posse. And if you haven't checked those out, again, I'll post links after a talk, go look at them. I built entire companies' infrastructure with those modules and writing very little Terraform myself because I'm super lazy. So I highly recommend looking at them. And that's the style that I'm looking to follow with the Databricks collection. But also, GitHub. So one of the things I've done with a few organizations now is start controlling their GitHub with infrastructure as code. I think there's very little that's as important as the code that controls everything. I do know of one particular company who ended up with a credit card skimmer being added to their website because they didn't control their GitHub accurately. I'm not going to say who. I think some of you already know. So you've got to be really careful with these things, right? And again, that's why it should be all managed by infrastructure as code. But there isn't a good set of GitHub modules. There's some that were in the community, but they got abandoned 2 years ago. So I'm adopting those. I'm going to create some others in the fashion that I've done internally for a few companies. And there's going to be more GitHub modules. So we have a full collection of those for managing GitHub. But I've got a good call to action. Every talk should have a call to action. So I'm kind of curious as to what you need next, right? There's really good modules out there for AWS, Azure, Google Cloud Platform. I think they've got one. There's good modules for Lacework out there. I'm creating the Databricks ones. What clouds are you running? What tools are you running? There's good modules for Opsgenie, I should say, as well. But what tools are critical to your infrastructure that you need modules for? I'd love to hear from you as to what modules you need, what collections would be useful to you. And with that, any questions?